Since I wasn't able to present to you guys in class, I just wanted to make a little video showing you what I chose to do for my activity. So I took a geology class this quarter and thought that all the stuff about plate tectonics, I thought all the stuff about plate tectonics was really cool, so I wanted to do some sort of activity, hands-on thing that played into that. So I found this activity for using graham crackers and Cool Whip actually would be, in this lesson, would be the mantle, and that's the layer below the crust. And then the graham crackers just make up pieces of individual crust. So in this activity, you'd start out by having students do the first part of the activity sheet, which I attached, which just makes predictions about what each one of these looks like. So we have the convergent, the transform, the divergent, and the subduction zone boundaries that we're going to demonstrate in this thing. And one of these is a little soupy. Apparently people go into the dollar store and inhale all the CO2 out of the can, so it was really difficult to find cans that weren't partially used, but I guess it's okay because I won't be eating it. So after they make the predictions, you want to model for them what it looks like, and I said in my lesson plan I thought the best one would be transform because you won't be really giving too much away by modeling that for them first. So I'm going to go ahead and show you in this one right here. In the lesson, you would take 2 graham crackers, tell them to put them side by side, and then they want to move one up while they move the other one back. And what they'll notice is they kind of get caught on each other, and then there's this release of energy when they move, and that's kind of supposed to symbolize what happens with earthquakes. For the next one here, we'll go ahead and do the subduction zone, and with one of these graham crackers, what happens in the subduction zone is that you have volcanoes that form, so when it subducts, the pressure here melts the mantle and it comes up and it forms volcanoes. So when you have these 2 graham crackers, I'm going to push one underneath the other, and if you look, you can kind of see that the magma, the mantle gets pushed up, just like that. And so in our next model, we have convergent boundaries, and convergent boundaries move towards each other. And so to symbolize this, you're going to take a cup of water like this and get both edges of your graham cracker wet, which is kind of gross. And then right over the top, this, when you push them together, whoops, didn't get it wet enough, but it kind of goes together like that, and then this uplift right here is supposed to symbolize the mountains that are formed. Like the Appalachian Mountains was an example used in the lesson plan. And the last one is divergent, and divergent boundaries happen when 2 oceanic plates move away from each other. So for this part, start side by side and you push down and away, and the mantle comes up to the center, and that's what is responsible for seafloor spreading. So that's the demonstration. You could adapt it for younger grades as well. Maybe not use quite as many. I would definitely recommend using Cool Whip instead of whipped cream like I used. It isn't as runny, and make sure that it actually is fluffy and not kind of wet and solid. But yeah, I chose to use middle school standards because those are the only ones I could find for next generation. But I think you could definitely adapt this and kind of maybe pair it with an engineering component or something like that if you wanted to make it standard aligned for younger grades.